And this is Jalen. All right. Now let's get set up for this slide. All right. We had done example 1 before, but examples 2 and 3 weren't on the slide set, so we're going to be using this slide to do example 3. But before we get started on that, let's just go over a couple of announcements. First, I want to say this because you are the prime candidates to be on the prime numbers. I mean, the prime, I can't think exactly what they call themselves. It's the math team, by the way. This is Walter. Okay. Just missing Gavin and Jake. Jake usually will make it. Who? Huh? Gavin? Okay, he's on the way. Oh, looks like we wound up with perfect attendance. So be sure to share this with them. The prime examples, that's what the name of it is. That's what the title of our math team is. That's what they go by. And it's also the math club, you might say. They meet every Friday on the Birmingham West Campus. I think it's 9:30 to 10:30 in the Science Building, which is C Hall, room C100. Okay? Please give it a shot. I have in my Monday, Wednesday class, I have a guy who's in Cal 2 now, and back when he first started calculus, he has been a while out of school. He was really, you could tell he was sort of deer in the headlights, about it. He started participating with that math team, and in just a few weeks, he was first response on every question. I mean, it gave him really good insight in what was going on. It's a lot of fun to that. In addition to that, and there's competitions and there's ways you can get recognized. So please, you are the prime candidates for it because you are in trig, okay, and going on to calculus. So it's I hope you'll be going on to calculus. So please give it a shot, and I think you'll find it's very beneficial. In addition to being fun, extraordinarily beneficial. Okay. Now, I think the only other thing I want to tell you about is Cougar Connection Week. That's next week now. I've been telling you it's coming up. Here are some of the activities that are happening. Monday on this campus, they're celebrating, and I guess Sunday that next week is Constitution Day. I didn't know there was one, but I guess there is because they're celebrating Constitution Day, and this will be in the faculty staff dining room that's just this side of the cafeteria in this building, Building A, from 12 to 1. There will be a special Constitution I'm sorry, I may be reading it. No, that's right. This is so hard to read. Yeah, that's what it says, Constitution Day. It's right in the middle of the background stuff, okay? So that'll be 12 to 1 Monday on this campus, faculty staff dining room. On the Birmingham campus, going on basically all morning from 8 till 1 into the early afternoon, will be Get On Board Volunteer Fair, okay? On the Birmingham West campus will be just outside the library. That is sort of a covered area out there, just outside the library, nice green space and stuff too. And that will be from 8 till 1. Some of the organizations that probably will be represented are the Ben Green Housing Authority, if you want to volunteer. Big Brother, Big Sister, BBBS, I almost missed that one. Bessemer Recreational Center, Faith Chapel, Girls Incorporated, Grace House, Hands on Birmingham, Humane Society, Metro Changers, Oaks on Parkwood, Operation Hope, Powership Network, and the Red Cross. Now let me also say this about the Red Cross. At one time, I think they were planning to try to schedule a blood drive sometime next week. I haven't seen any details on that. So watch out for that as well. Now, also get on board student organizations. Student organizations you might want to consider joining. There's ambassadors, athletics, fine arts, honors college, PBL, Phi Beta Lambda, Scholars Bowl, Student Government Association, speech and debate, SSS, Student Support Services, or still our math team, the prime examples, okay? They left that one off, I don't know how, okay? So those are the things you can do. That's Monday, 8 to 1. On Tuesday, they flip, okay? On this campus, it'll be Get On Board, Volunteer Fair, and this will be outside of our library, which if you picture where our library is down there, you go out the door, outside of that, there's a little courtyard between the A building and the B building. That's, I think, where it's going to be. And that will be from 8 to 1, Tuesday. On the Birmingham campus, they'll have their Constitution Day, and that will be in Thelma Catlin Auditorium, which is in the library building, and it's hard to find sometimes. Just ask any librarian you happen to see, and he or she can direct you to Thelma Catlin. Right there, really close, in Building B, and that will be from 12 to 1 there. Okay? I'll wait and announce the Wednesday and Thursday stuff next Tuesday. It'll be coming up here. You can see these signs all over campus and see what's going on. And as was threatened, Gavin did show up. Okay, good deal. All right. Any questions? Just ask, okay? Any questions on anything that's happening or that we've done so far? All right. And again, we're on Chapter 4, Trigonometry, 4.4, Trigonometric Functions at Any Angle, and on page 289, Example 3, Trigonometric Functions of the Quadrantal Angles. What in the world do we mean by the quadrantal angles? Well, the quadrants are these four divisions. There's the first quadrant, second quadrant, third quadrant, fourth quadrant. So the quadrantal angles are 0, pi halves, pi, 3 halves pi, 2 pi, and all around and around either direction. Those are our quadrantal angles. Because remember, acute angles are anything inside the first quadrant, obtuse angles anything inside the second quadrant, and then we have the others down here, but we haven't talked about what's on the boundaries of the quadrants. Okay, those are the quadrantal angles. And I think you know them all, okay? But let's just review them. Evaluate the sine, the cosine, and tangent functions of the quadrantal. Let me get my pen set up. Okay? Of the quadrantal angles 0, pi halves pi, and 3 halves pi. So we're looking for cosine and tangent. Right? Yeah. Tangent of these angles. 0, pi halves, pi, and 3 halves pi. Okay. Got it. What's the cosine of 0? 1. Perfect. The cosine, well, let's just go and do tangent of 0. What's the tangent of 0? Undefined, because tangent is sine over cosine. No. Yeah. Wait. Tangent of 0, no, is 0. Sorry about that. I jumped to the next one. Okay. Whoops. Wrong thing. The mind's not. A mind is a terrible thing to lose, you know. So let's see if I can get back and get my eraser. Okay. What's the tangent of 0? Second? Tangent of 0 is? 0 over 1, which is? 0. All right. Cosine of pi halves. That's 0. That makes the tangent of pi halves undefined because you can't divide by 0 because it's 1 over 0. Okay? Then the cosine of pi, -1. Perfect. And the tangent of pi, it's 0 again. You got it. Okay? And the cosine of 3 halves pi, second, 0. So the tangent of 3 halves pi is what? Undefined because it's 1 over, sine over cosine, and you can't ever divide by 0. Okay. Make sense? And guess what? You could do all the other 4 trig functions for all those 4 angles as well. They didn't ask for them, but they're just as easy to get. All right. Any questions? And guess what? The sine and the cotangent functions are what your checkpoint are asking for. So as soon as you get out of class and have an opportunity, do your checkpoints, and the audio-video solutions to those are at larsonprecalculus.com. Any questions on that? None? All right. And if nothing else, for those angles, pick out where they are on the unit circle, the ordered pairs. Of course, at 0, it's 1, 0. Pi halves, it's 0, 1. Yeah, if you pick out those, it'll be maybe easier to see what those values are. All right, let's go through this. Now let's deal with reference angles. Okay? Now I'm going to give you 2 characteristics of a reference angle. Number 1, always acute. Okay? Second, always positive. No matter where they are, your reference angle is always an acute angle and always a positive angle. Okay? And here's Jake. Perfect attendance. Ding, 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 ding. Way to go, folks. Okay. Now, what are we talking about with reference angles? Here's just a little bit of background here. We're trying to determine the trig functions of any angle. Not just acute angles, not just obtuse angles, but any angle you happen to find, positive, negative, wherever, anywhere on the graph. Okay? Well, there's 2 characteristics of those. And you're wanting the trig functions of. First is the sign of those angles. We've already talked about that. All the angles are positive here. Only sine and its reciprocal cosecant are positive here. Only tangent and its reciprocal cotangent are positive here. And only cosine and its reciprocal secant are positive there. So you got the signs on SIG and signs of the angle. But after that, what's the value of those angles? Well, that's where the reference angles come into play. A reference angle, here's the 3rd characteristic of the reference angle. Number 1, always acute, always positive. No matter which way it happens to be heading here. The other thing, it always has one of its sides being the x-axis, not the y-axis, the x-axis. Always. So you have a reference angle here. Well, that's just your angle. Don't usually talk about reference angle with the first quadrant, which is good. That's just the angle. The reference angle here would be this angle with the x-axis here, and that would be that angle. Positive angle, remember, acute angle. Okay, down here it would be this angle. X-axis, acute, positive. Down here, x-axis, acute, positive. Don't, just because it's going down that way, don't count it as a negative angle. It's not. It's a positive angle. So those are your reference angles. That's my arm waving. Let's see how they describe it here. The value of the trigonometric function is greater than 90 or less than 0. In other words, negative angles down here, anything obtuse or beyond, up, top, okay, can be determined from their values of the corresponding acute angles called reference angles. Okay? You'll deal with, this deals with their values now, not their signs. You get their signs separately. but the values. So here's the definition of the reference angle. Let theta be an angle in standard position. Its reference angle, wherever that is, whatever quadrant it is, its reference angle is the acute angle, and they call it theta prime. Some books call it theta r for reference, okay? Theta prime formed by the terminal side of theta, whatever that angle was, and the horizontal axis, okay? Notice again, acute angle. Now they don't say it, but it's always a positive acute angle, theta, formed by the terminal side of theta and whatever the closest horizontal axis is. That's your reference angle. Always acute, always positive, and always with the horizontal axis. Okay? So let's look at it. If this is your angle, and obtuse angle here, theta, here's your reference angle, theta prime. From that terminal side to the closest x-axis, horizontal axis, that's your reference angle. Okay? Now, in the second quadrant, how do you get it? Well, here's pi. Subtract from pi your angle theta, and that gives you your reference angle. Always positive, always with the x-axis, and always acute. Okay? Down here, here's your reference angle. If you're over in the third quadrant, here is the terminal side. The reference angle is the acute angle between the horizontal axis and that terminal side. Well, here is that angle theta minus pi, because you see you're subtracting pi from this to get that angle. Here it's pi minus the angle. I don't ever try to remember what the formula is for each one of these. I'll look at it and say, well, that's short of pi here. There's your closest side, pi. So this angle here would be pi minus whatever that angle is. Over here, it would be that angle minus pi. Okay? Just look at it to see what defines that reference angle. And it happens to be theta minus pi or theta minus 180 degrees if you're in degrees. Okay, if you're in the fourth quadrant, guess what? Here's the reference. If your terminal side is in the fourth quadrant, the reference angle is the angle between that terminal side and the horizontal axis, closest horizontal axis. That would be this acute angle here, positive, always positive, and how do you actually determine it? Well, 2 pi or 360 minus this one will give you that. So, again, I don't try to memorize those formulas, but I look at them and see. That's how I get it. It's that angle that's left over. Does that make sense? So, of course, in the first quadrant, your angle is your reference angle, because it's for the horizontal axis and it's acute. All of them keep there. Does that make sense? All right. So let's find these reference angles. Okay? Now, frankly, I like to draw pictures. Okay? I don't draw good pictures, but I like to draw them. So if this is your thing, where in the world are we if theta is equal to 300 degrees? Fourth quadrant, you're down here, because that would be 90, 180, 270, 360. It's in between 270 and 360. So it's going to be down here, somewhere like that. So that is the angle 300 degrees. Okay? Theta equal 300. Okay? What is your reference angle? Yes, it's the angle left over to the horizontal axis, and that obviously is going to be 60 degrees. So theta prime is equal to 60 degrees. Does that make sense? Because it's one circle minus the 300, that would give you 60. Because one complete circle is going to be 360. That's 300 of those 360s. That leaves you 60 to go. That's your reference angle. Does that make sense? All right. Let me erase part of that. And you can use the formulas if you want to, but that to me is just so much easier to do. All right. This is bizarre, isn't it? Okay. Here's your angle theta is equal to 2.3. What does that mean? Radians, because you do not see a degree symbol. If it was a degree symbol, it'd be 2.5 degrees. That would be the reference angle because it's in the first quadrant. This is 2.3 radians because you don't see the degree symbol. Where in the world is 2.3 radians? It's what?
You can get the fraction from 2.3.
Okay.
Get a fraction instead of decimal.
Okay. Here's how I would do it. You're probably doing well, but here's how I think of it really simply. I know this angle. What is it? Well, but think in radians. Pi. And pi is approximately 3.1416. We don't need that many, but 3.14 would do. And this is half a pi, right? Which would be 1.57, okay? Approximately, right? And guess what? 2.3 is in between 1.57 and 3.14. So we're somewhere in the second quadrant. I don't know where, but we're somewhere in the second quadrant. What is its reference angle? So here's the angle. Let me get a different color. Give me a color. Blue? Light or dark? Dark, okay. We'll get dark blue here. All right, here is our angle theta. Theta equal 2.3. Radians, okay. What is its reference angle? That difference there, you're absolutely right. This is the reference angle, theta prime. And how do we get it? Let's subtract 2.3 from 3.1. Okay, we don't have two digits in one, so you can't have more than two in the other. And this gives you what? 0. Anyone do it? Hard math, huh? Second? Oh, pull out the old calculators here. Who can subtract anyway? What do we get? 0.8. There's your reference angle. Theta prime is approximately 0.8. Okay? Now, I bet you the book's going to give a lot more decimal places than that. But guess what? You really can't. If you only have two digits there, you can't give me any better than two. Well, you know, that's the best you can do. The book said 0.8416. Well, where did they get all those digits if that's on? If they said 2.300, I would agree with them 100%. Or 000. Yeah, that would be exactly right. But, you know, with just 2.3, 0.8 is really all you can do. But that's in physics. That wouldn't be, I guess, pertaining to math. Okay. Now, the third one. What if theta is minus 135 degrees? Where in the world is that, Waldo? Okay, let me get this erased so it won't be as messy. Okay. All right, and we'll go back to black or dark. Okay. And where do you say we were? Third quadrant, okay. Yeah, this is minus 90. That's minus 180, so we're somewhere in between. In fact, I think we're right there in between. So here's our angle theta is equal to negative 135 degrees. Now, because they do it in such a convoluted manner, they first get the coterminal angle that's positive, then they do their subtraction. Why go through all that? Just take a look at it and see what is the angle between that terminal side and the closest horizontal.
Is it 225?
Say again?
Is it 225?
2.5, is that what you said?
225, I think it's what
Okay, yeah, you're doing the coterminal angle, which is a good way to do. That's what the book does. But I look at this and say, hey, that's the difference of that and 180, right? So 135 to 180, and you can do the minus 180 if you want to. It doesn't matter. That's where you're going to. And the difference between those, if you're subtracting that, that's the same as adding, and that's 45 degrees. Exactly. Exactly. That's exactly 45 degrees. So your theta prime is equal to 45 degrees. Always acute, always positive, and always going to the x-axis, from the terminal side to the x-axis, closest x-axis. Okay, so that's how we get these reference angles. It's really a pretty straightforward process. I'm going to clear my scratch here, and let's look and see how they got theirs. Well, I didn't need to clear it. They went to a new page. 300 is in the fourth quadrant, and then they use their little formula, which is fine if you want to remember them that way or write them down, however. But if you're in the fourth quadrant, you're going to the horizontal axis above that. How many degrees difference between 360 and 300? That would be your acute angle 60. Okay? In degrees. That's why the little degree symbol's there. Okay? And here they show it, and you can see the reference angle is over there at 60 degrees. Make sense? Always positive, always acute, always to the horizontal axis. Okay, 2.3 is in radians. It's between pi halves, which is 1.57, and pi, which is 3.14. So therefore, it follows it has to be in quadrant 2. The reference angle would be pi minus that. I don't mess with the formulas, really. I just look at the pictures. There's the picture. There's the angle, pi 2.3. The difference in that and the horizontal line, which is the pi, which is 3.1. That would be your reference angle. Okay. Pi minus, okay. Now, again, they carry out 4 digits that I don't know where they get them. Okay, I know where they got them. But that would only be true if that was 2.3000. If you knew that was your angle, then you could give me that many digits as your answer. Okay. Now, next, negative 135. They say it's coterminal with 225. Yeah, you can go that route, but just draw negative 135. That's between negative 90 and negative 180. Draw it in there, and you know the difference is that to 180. So it's the difference between 135 and 180. You can forget about the signs because it's a positive number, okay? And they did the 225 minus 180. It works the same way, but they had to do 2 calculations to get it. We only had to do 1, 45 degrees, okay? There we have it. And here is minus 135, which is what we did. Why mess with that? You could just say it's between the horizontal axis and the terminal side. What is that angle? Well, this is 180. This is 135. That would be 45. You can sort of forget about the signs there because your reference angles are always positive. So the difference is 45 degrees. Does that make sense? You can do it their way too, go to the coterminal angle and then using the formula. Just look at it and see what it is. Make sense? All right. Now, there is a checkpoint there. I would definitely do the checkpoint as soon as you can after you get out of class. And that, if you have trouble with it or not certain of what the answer is, go to larsonprecalculus.com. And they'll have audio and video solution. So really worth your while. So now we're finally ready to do trigonometric functions of real numbers, which, if my memory's right, that's the title, almost the title of the section. It's trigonometric functions of any angle. This is trigonometric function of any real number, which would be any angle. So, to see how the reference angle is used to evaluate the trig function, consider a point xy on the terminal side of theta, shown here. Okay? Now, here's your point xy. There's your x. You see it's a negative number. There's your y. You see it's a positive number. It's still the opposite side. That's still the adjacent side. Y is opposite. X is adjacent. Okay? Now, And this to me gets a little crazy, but it's fine. It's how they do it. They take the absolute values of each of those to keep them all positive. Okay? Then your theta prime can be positive, and everything can work out just like you would do. If you're looking for a sign, opposite over hypotenuse. By the way, the hypotenuse is always positive because it's the positive square root of the sum of the two squares. Okay? So you can always determine R. That's usually the first thing you do. Once you know what these two values are, the square root of x squared plus y squared is r squared. I mean, square root of x squared plus y squared is r. X squared plus y squared is r squared. So root of it. Positive square root. Always a positive number. Okay? Now, here's a little timeout here. If you had gone this far, why go to absolute values? The sine of this is y over r. The cosine is x over r. You got it right there. Using the sign, not the absolute value, using the sign. That makes the positive, the sine of this angle here positive. Makes the cosine negative, which of course you know is true. So you're doing the same thing. Why mess with, sometimes it's better to think in terms of reference angle, but here you take away the signs, use the reference angle, and then you put them back in to determine which quadrant you're in. Well, why do that? Just use the point, x, y, negative, positive, and all the trig functions work out exactly correctly using those signs. So, either way you want to do it, they're using absolute values, so it's fine. If you use absolute value, you've got to use reference angle. Okay. So, by definition, you know that the sine is y over r, cosine is x over r, tangent is y over x. Did they just ask for, I don't know why they just put tangent in. For the right triangle with acute angle theta prime, why didn't they call that reference angle theta prime? I don't know, but it is an acute angle, but I wouldn't call it reference angle theta prime. And the sides of those lengths, then the sine of that theta prime is your opposite over hypotenuse, which is absolute value of y over r. The tangent of theta prime is opposite of that, which is absolute value of each of those. Okay? And that will give you, and once you have the sides of these, and we had these trig functions, which are always positive because you're doing acute angles and you're doing only absolute values, then assign the SIGN sign to it. If this is second quadrant, it stays positive. This is second quadrant, it goes negative. So that's the last step. You go back and put the signs in. But guess what? If you had not used absolute values, you get the sign correct and the value correct. Everything would be correct. So I wonder why do this, but anyway, that's how they do it. So it follows. It's the way they've always done it. You know, actually, it does go from back when they had tables of sines and cosines. You didn't have calculators that were given to you. When you had tables, they were always positive. So all you did was look at what quadrant you were in. You get the reference angle that corresponded to that, and the quadrant gave you the sign. So this is really flashing back to those old days. So it follows that the sine of theta and sine of theta prime are equal, except possibly in the SIGN sign. And then you just look at which quadrant you're located, and that gives you that. The same is true for tangent and tangent time, theta prime, okay? And all other four trigonometric functions. In all cases, the quadrant in which theta lies determines the sign, SIGN sign, of the function value. Okay? Or you could have just used the xy coordinates without taking absolute values, and you get them perfectly that way too. Why not do it that way? I don't know. Evaluating trigonometric functions of any angle, find the value of the trigonometric function of any angle theta. First determine the function value associated with the reference angle theta prime. So you first figure out what theta prime is, then do the function that you're looking for of that theta prime. It's always going to be positive because theta prime is always acute. And then, depending on the quadrant in which it's located, affix the appropriate sign to that. Okay? it works, and it works well, okay? And sometimes it's the easiest way to think of it. But if you have the coordinates, all you have to do is put them in. That's what they showed you having. So, there it is. Okay. You can greatly extend the scope of exact trigonometric values. For instance, if you know what the function values are 30, and you better know it by now, 30 degrees, then everything else, all the reference angle 30 degrees, would have exactly the same value. It's just the signs might be wrong. So you've got all those under control now. So here's a table that lists some of these. Okay? Degrees and radians. You've seen this table before several times. 30 degrees, which is pi 6, 45, which is pi 4, 60, pi 3, 90 pi halves, and we know those two as well. Those of you who haven't been in the table before. The sign of 0 is 0. That's opposite over adjacent. The opposite is y value is 0, the adjacent is 1. Okay, sine of 30 is 1/2. 45 is square root of 2 over 2, square root of 3 over 2, 1. So you think of this square root of 0 over 2, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, square root of 4 over 2, square root of 4 is 2 over 2, 1. Those work. Okay? Cosine, just reverse. 0, 1/2, just like this. Just go backwards on it. Or start with a 1 and go down. Square root of 4 over 2, 3 over 2, 2 over 2, 1 over 2, 0 over 2. Go that way if you want to. Okay. And tangent is in the ratio of these two. 0 over 1 is 0, 1 over root 3, root 3 over 3, root 2 over root 2 is 1, root 3 over 1 is root 3. But at 90 degrees, 1 over 0 undefined, 0 over 1 is 0, negative 1 over 0 undefined. Okay. Then, I guess this is the other part. Thinking of 180, subtract 30 from 180, and you would get this value. Subtract 45 from 180, you get this one. 60 from 180, you would get that. Because that would be your reference angle. And add 30 to 180, and you get this one. Add 45 to 180, add the other. Then down here, subtract this from 360. Oh, they don't show 360, but that would give you the fourth quadrant. They don't show the fourth quadrant here. Extend your table and take these values as well. All right. Now, these are the common angles. A little less common, but still calculable, are multiples of these going around the rest of the circle. So let's evaluate some. What is the cosine of 4 pi over 3, or 4/3 pi? Well, where in the world are you, Waldo? I always like to start with a picture. Here's 1/3 pi, 2/3 pi, 3/3 pi is here, 4/3 pi is down here. Where are you? Third quadrant. Okay? Now, since they didn't give you the XY coordinates, then the easy thing to do would be use the reference angle. What is your reference angle then? If this is your theta, what is your theta prime? Say again? Okay, I would subtract pi from that. It's this angle right here, and remember, each of those was a third of an angle. See, pi over 3, pi over 3, pi over 3, pi over 3. So this is pi thirds, right? Subtract 3/3 pi from 4/3 pi, and you get pi thirds. And what's the cosine of pi thirds? Okay.
Is it a negative 1/9?
What's that?
1/9.
1/2. Okay, but in the third quadrant, what is cosine? Negative. Okay. I should have done the first. When I said, where were you, Waldo? You're in the third quadrant, cosine's negative there. Should have put the negative sign right there. Then figure the reference angle, pi thirds. Cosine of pi thirds is 1/2. 1/2 follow the minus sign. Okay, tangent of negative 210. Where in the world are you then?
First quadrant.
Say again?
Is it the first quadrant?
Okay, let's see. Hi. Okay, never mind. Okay. Negative 210. Here's negative 90. There's negative 180. And negative 210 will be between negative 180 and negative 2. Second quadrant. All right, we got it. Negative 210. Okay. About like that. Okay. Past negative 180 up this. How far past 180 did you go? Second? How far past negative 180 did you go? Second? 30. So the reference angle, theta prime, is 30 degrees. Always positive. Okay. Now, if you're in the second quadrant, what is the SIGN of the tangent? The sine of the tangent. Okay, wait. Sine of tangent in the second quadrant. All students take calculus. Yes, negative. Tangent is positive down here, here, and here. So it's negative up there. So that's going to be a minus. Now you figure out what the tangent of 30 degrees is. Anyone remember?
Is it radical 3/2? 1/2. It's negative radical 3/2.
Okay. All right. This would be, so we're dealing with 30 degrees now. That would be sine of 30 divided by cosine of 30. Right? That's what tangent is, right? And what's sine of 30? I think you just said it. 1/2. And cosine of 30 is? Radical 3/2. And the ratio of those is? Okay. Okay. The minus is minus root 3/3. Or you could say minus 1/√3. It depends. They'll probably put it in that way. So I think that's what you were saying. Absolutely correct. Okay? Sorry. Itchy nose. Cosecant of 11/4 pi. Ew. Well, if we're, let me erase my mess here. Okay. All right. All right. 11/4 pi. There's 1/4 pi, 2/4 pi, 3/4 pi, 4/4 pi, 5/4 pi, 6/4 pi, 7/4 pi, 8/4 pi, 9/4 pi, 10/4 pi, 11/4 pi. Okay? Now that was a long way to do it, but you could do it that way. Actually, a lot easier is to divide 4 into 11. How many times will it go? So yeah, that would be 2 pi with 3/4 pi left over, right? So 2 pi is one way all the way around, then 3/4 of pi would be 1/4 pi, 2/4 pi, 3/4. You find that the same place. Okay? So, where are we, Waldo? Second quadrant. What is the cosecant in the second quadrant? Positive or negative? Positive, because it's reciprocal of sine. And all students take calculus. Sine is positive in the second quadrant. So cosecant is. There's going to be a positive number. What's its reference angle? Theta prime is that angle right there. What is that? 45 degrees. And what's the, does anyone remember what cosecant of 45 is? Bet you do remember what sine of 45 is, don't you?
It's
Radical 2 over 2. Or you could have said 1 over root 2. And then when you reciprocate it, that just gives you root 2. Because cosecant is reciprocal of sine. So it's just root 2. Make sense? Positive root 2 because first or second quadrant, sine and cosecant are positive in the second quadrant. The only two trig functions positive in the second quadrant. Why did I say 45 degrees? Somebody said that to me. You should be saying pi fourths, which is same thing. The one above was in degrees. All right, any questions? See how it works? First determine where you are. That'll give you the SIGN, sine of whatever function you're dealing with. And then do the reference angle, and that gives you the value of the function. Then put the sign with the value. And you got it. All right. That's how we did it. Let's see how they did it. I'm sure it's going to be a little different, and I think a little more convoluted, but let's see. The first, because theta equal 4/3 pi is in the third quadrant. It's greater than pi, but less than 3/2 pi, so it's in the third quadrant. Your theta prime would then be pi thirds. What we're looking for, they don't have the problem here. I don't remember. What was it? Cosine? Oh, I didn't turn the page. That's why I can't see it. Yeah, cosine. Cosine in the third quadrant, negative. So you can put your minus sign down and then do the cosine of pi thirds, and you'll have it. Okay? So third quadrant. So your sine's going to be negative. And it's negative the cosine of your reference angle, which is pi thirds. And we know what cosine of pi thirds is, 1/2, so that's negative 1/2. So the quadrant tells you what the sine is, SIGN sine, and then the reference angle, the trig function of that reference angle will tell you the value. Okay, here. Now, again, they do it rather strangely. I mean, it's perfectly fine, but rather than adding 360 to it and getting 150, why don't you just count around? Negative 180, and then you go 30 more degrees past 180 to get negative 210. There you have it. You have the reference angle of 30 without having to go through this, okay? But that puts you in the second quadrant. And what trig function are we dealing with here? Tangent, yeah. And tangent is negative in the second quadrant. So, it would be the negative tangent of 30 degrees because you're 30 degrees past negative 180. Okay. So that gives you a reference angle 30 degrees, second quadrant. Tangent is negative there, so you know the answer is going to be negative. And then tangent of 30 is, as we calculated before, root 3. Root 3 over 3, negative root 3 over 3. Okay. All right, any questions on that one? Goodness, I'm losing my voice. Okay. Then the third one, the C one. This one, it does sort of make sense to subtract 2 pi from it because that's well more than 2 pi. That's 2 3/4 pi. So subtract 2/3 from it, and you get 3/4 pi. Okay? Well, where is 3/4 pi? That's in the second quadrant again. Okay? So it's coterminal over there. You're in the second quadrant. This time you're dealing with cosecant. Cosecant is positive in the second quadrant, So it's going to be whatever the cosecant of pi, the reference angle is pi quarters. Okay? Because you're that far short. Okay? So the cosecant of pi quarters is 1 over the sine of pi quarters. And a little positive now. Sorry. My head's clogging up. Sine of pi fourths is root 2 over 2, or 1 over root 2, another way to write it. And when you do 1 over that, you just get root 2. All right. Example 5. Any questions? Again, there's a checkpoint right underneath it. 3 more to do. Well worth your time and effort to do them. And if you have trouble with them, LarsonPrecalculus.com. Don't need a code. You don't need anything. Anyone can go to it anytime they want to and get the assistance. You don't even have to be taking the course. Anyone, Joe Blow on the street. My wife could go and sign up and just enter LarsonPrecalculus.com. She would see all this, wouldn't know beans about where it came from, but she would know access that. Well, guess what? They skip example 6 and 7. So let's do example 6. I keep forgetting to get my... All right. Example 6. Let theta be an angle in quadrant 2. All right. They already told us what quadrant it's in. Quadrant 2. Okay. Such that the sine of theta is 1/3. Okay. So you're in quadrant 2. Okay. And they told you the sine of angle theta is 1 over 3. Not one of our favorite ones, is it? We don't know that. Okay. Now, time out. Are these two pieces of information consistent? That the angle is in quadrant 2, but the sine is 1/3. Is that consistent? Yes, because sine is positive in the second quadrant. Yes, so that is consistent. Now, when I see sine of theta is equal to 1 over 2, 1 over 3, okay, what immediately comes to my mind is sine is what over what? Y over R. Perfect. Okay? So, if R is 3, then I'm going to draw, again, I like to draw things, though I'm lousy at it. Okay? I'm going to draw a 3 circle. Not a unit circle, a 3 circle. Now, mine really stinks. My circles are really, really lousy. Okay? Not very circular, but got it. And the Y value is 1, and the R value is 3. So there is my angle approximately right there. There's your theta. 1 over 3. Y is the 1, and 3 is the radius. That's why I drew a 3 circle. All right. Before I read the rest of the problem, that's what I see. Let theta be an angle in quadrant 2 such that sine theta is 1 over 3. Now what we're asked to find is cosine theta. Can we do that, Waldo? Say again? This isn't one of our favorites, so you can't just pop it out. What we know, the opposite side is 1, and the radius, or the R is 3. And that gives you the x. What would the x be then? Anybody? Help me, help me. Say again?
2.
2? That's a new one on me. Isn't it?
Wouldn't it be? Yes, 2. Oh, I thought it would be 2, 2. Because the hypotenuse is 3.
Right.
So we got to do Pythagorean theorem on the variable for x.
Okay.
Yes, 2.
Okay. Tell me how Pythagorean theorem goes. I tend to forget it.
3 equals square root of x squared plus 1 squared.
All right. You said 3 is equal to the square root of x squared plus 1 squared. Is that what you said? Okay. Can I square both sides? Would that be legal? Yeah. 9 would equal x squared plus 1, right? So x squared would equal 8. So x equals the square root of 8. Now that's fine, or you could write it as 2 root 2, right? Because you can factor out a 4 out of 8. Square root of 4 is 2, and left is square root of 2. Either one of those is fine. Okay? That's your x value. Either one of those. That's your x value. So then cosine would be the square root of 8 over 3, or you could write that as 2 root 2 over 3. Okay. And what else did they ask for? That was cotangent and tangent. Tangent of theta. Oh! What is tangent of theta?
1 over x.
Which is?
1 over 8 squared.
The square root of 8. Okay? And you could call that the square root of 8 over 8, which, remember, square root of 8 is 2 root 2 over 8, which would be square root of 2 over 4. Okay? Now, except, what have we forgotten? Those are the values. Yes, we want the sign. Actually, we'd have gotten it right if we said x equal negative root 8, because in the second quadrant it's negative. So this would have been a negative, and that would have been a negative. Okay? Both of those would have been negative, because cosine and tangent are negative in the second quadrant. Only sine and cosecant are positive there. Okay. So, the cosine is negative 2 root 2 over 3, and the tangent is negative root 2 over 4. Good for them. Do you see that? All right. There is a checkpoint there too. That one I think really could use some going over. Okay? So please practice on that one. All right, to erase? I'm sorry? Okay. Okay. Actually, I was going to pass out the test today just so you might have a little extra time to work on it. We probably aren't quite going to finish, but I think it's in here somewhere. Okay. There you go.
Yeah, thank you, Dr. Farrell.
All righty. Anytime. Okay. Okay. All right. Everybody got this one? Let's see if we can squeeze in example 7. All right. Use a calculator to evaluate each trigonometric function. Okay? How in the world would you do cotangent of 410 degrees?
Make sure it's in degree mode.
Ah, absolutely. First thing to do is make sure you're in the right mode. That would be degree mode. Then what?
And then you put 1 over tangent of
That would be 1 over the tangent of 410 degrees. And guess what? Your calculator isn't going to care. It'll do it. You don't have to change that to a reference angle or a coterminal angle or anything else. It'll do it. And it'll do it correctly.
Except on the sign, or did it already do it?
What's that?
Except on the sign.
The calculator will do it all. Okay? Sorry about that. It's not nearly as much fun with a calculator. You don't get to do all the figuring on it. Okay? That will do it for you. Someone do that and tell me what you get.
0.839.
Got it. Good deal. Okay? That's in the book. They say 0.839. I'll stop there too. They give 4 more digits, but that's fine. Okay, now, because I like to think in terms of these things, what is 410 degrees? Well, that would be 90, 180, 270, 360. Okay? And then 410 would be between that and 450. So yeah, in the first quadrant, everything's positive in the first quadrant, including cotangent. So at least the sign's right, okay? And the number is too. All right, the B part here says the sine of -7. How would you go about finding that?
Switch over to radian.
Yes, you better be in radian mode. That's not 7 degrees. That's 7, which means radian mode. And then all you do is do the sine. If you're in radian mode, -7. You got it. I mean, it's just, that's all you have to do. But I want to think through it to make sure it's going to tell me the right answer. Don't you want to do that? Okay. Well, over here is about 3. Over here is about 6.28. Okay. 7's not, oh wait, I was going the wrong way. Over here is -3. Over here is -6.28. You're somewhere down here. Which quadrant? Fourth quadrant. And sine in the fourth quadrant is negative. So it better give me a negative answer. What does it give you?
Negative 0.656 or 657.
Okay, something about that. We'll put approximate. Okay. Okay. And sure enough, that's what they give you as well. Okay. How about secant of pi ninths? Okay. How would you find that on your calculator? Yeah, okay. You stay in radian mode if you're already in it. Get in radian mode. Then you do what? 1 over cosine of pi over 9. And guess where you are, Waldo? Pi ninths is in the? Is what? First quadrant, yeah. Anything less than pi halves is in the first quadrant. Okay, and this is pi ninth. Just a little ways up there. So you expect your answer to be positive. Okay, and sure enough, and you also expect your answer to be okay, positive, but big number, small number.
It would be greater than 1.
Greater than 1 because it's a secant. And you're dividing by something less than 1. Sine, you know it's going to be between -1 and 1. It was. Cotangent, tangent, you can never tell. You can tell the sine, but that's about all. This one, you know the sine here because you're which quadrant you're in, and you know the value is going to be between -1 and 1. Here, you know this is going to be, since it's in a positive value, it's going to be greater than 1. And how much greater than 1? What does your calculator tell you? 1.064. Okay, that sounds reasonable because your cosine is just, I mean, pi ninths is just a little bit more than pi, other than 0, right? Just a little bit more, okay? So you haven't gone far past, and secant starts at 1, just like cosine starts at 1. So you've just gone a little bit up from there. 1.064 sounds pretty reasonable to me, and that's what they got. All right, again, the checkpoint has 3 more calculator calculations, so go for that. All right, let's see if we can squeeze in our vocabulary here. In the first 6 exercises, let theta be an angle in standard position with xy a point on the terminal side of theta, and r is equal to the square root of x squared plus y squared, which is not equal to 0. All right. Fill in the blanks. What is sine of theta in terms of x, y, and r? What is sine theta? Huh?
X over R.
Really? Sine theta?
Oh, Y over R.
Y over r, okay. Number 2, what is r over y?
Cosecant.
Cosecant theta, okay, very good. What is tangent theta? Y over x. What's secant theta? R over x. What is x over r is number 5. X over r. That's cosine of theta. Okay, and what's x over y? Cotangent theta. Bingo, you got it. Oh, you can't say that in Alabama. Okay. Because r is the square root of x squared plus y squared, cannot be what? There's 2 things it can't be. It can't be 0. It can't be negative. Okay. The sine and cosine functions are blank for any real number, any real value of theta. There could be a couple words they're looking for. I think the easiest one would be defined for any real number theta. It could be, yeah, that would be the easiest. I think continuous would be another word you could put there. The functions are continuous for any real number value theta. So I think defined is probably what they're looking for. Number 8. The acute angle formed by the terminal side of an angle theta in standard position and the horizontal axis is the blank angle of theta, and it's denoted by theta prime. Reference angle. Good deal. All right, homework exercises. Do either 9 or 11. They're both at Calc Chat. 11's at Calc View. Do any of the odds 13 to 17. They're all at Calc Chat. Do 19 or 21. They're both at Calc Chat. Do any of the odds 23 to 29. They're and even 31. They're all at Calc Chat. 25's at Calc View. Do either 33 or 35. They're both at Calc Chat. 33's at Calc View. Do any of the odds 37 to 45. They're all at Calc Chat. 39's at Calc View. Do any of the odds 47 to 53. They're all at Calc Chat. 51's at Calc View. Do any of the odds 55 to 67. They're all at Calc Chat. 55's at Calc View. Do any of the odds 69 to 73. They're all at Calc Chat. 73's at Calc View. Do any of the odds 75 to 89. They're all at Calc Chat. 81's at Calc View. Do any of the odds 91 through 95. They're all at Calc Chat. 91's at Calc View. And then on the applied problems, do any of the odds 97 through 101. They're all at Calc Chat. And then true false, there's 103. Should be at Calc Chat. There's a writing, which I doubt if it's going to be at Calc Chat, but you can look at that if you'd like to. All right, any questions on 4.4? Okay, we have come very close to running out of time, which means that, and we did finish 4.4, so it is time for the test. But I got it ready anyway, whether we were going to be time for it or not. I don't know where they threw a bunch of junk in my. Here we go. All right. Oh man, it's stiff from sitting too long. Here's your test, and I bet this water. Okay, that's why it's take home. Okay. Oh, good catch. Now, I'm going to have some more back here somewhere else. I'm in deep trouble. Was. For some reason, didn't get stapled. And why am I short one? Do either one of you have? Can you hang around just a minute for paperwork? I don't know why. I think I'm short. Must not have made enough copies for me. Let me run down to the copy machine and get. Well, did she keep my original one? Can't imagine she did. There's the test one. There it is. Can I be yours for a moment? I think this is the same version. I may have to borrow yours back because I can't seem to lay my eyes on. Why is this in the middle of? She must have got my original stuff. Let me use yours to make his copy. Sorry about this. And they'll make me a new original copy. If y'all want to come down, where are you heading next? You have another class or going downstairs?
Yeah, I'm quiet.
Okay, well, if you come with me, I'll make a copy real quick. take on?
Okay, that's a lot better. A lot better. A lot better.
Okay.
That was really worst case scenario. You said, I was hoping you were gonna say no. It wasn't a quiz. You missed nothing. There was a quiz, and that was gonna be your first assignment, and that was gonna be my first year.
Okay. Things have gotten separated here somehow.
Oh, are they two separate assignments? Or?
No. Well, here's the quiz,
That's great.
and you need graph paper.
You are.
Okay. The wrong one graph. Okay. There was my original.
On this quiz is gonna be most of everything you learned this week, right?
What's that?
This quiz is gonna be most of everything you learned this week, right?
That would cover sections 1, 4, 1, 5, and 1, 6. And it's not everything, but it covers most of it. And where we got to today, we finished 1.5, just have one more example to do of that. So a few more homework problems at the end of 1.5, and then most of the homework problems in 1.6. But if you listen to the YouTube video, you'll hear all that done.
Yeah, that's probably pretty good.
What's that?
Yeah, you said it was like a YouTube video was on Blackboard or something?
Yeah, through Blackboard. Yeah.
That sounds good.
It's everything we did in class. So you can follow that. It's not there right now, but it will be there really soon.
Well, I mean, even if that's not there right now, you still have what, 1.4 and 1.5 there?
Yeah, we did. We finished 1.5 and 1.4 and the most part of 1.5, but it's going to be out there as soon as I can get it done right now. So, good deal.